So now let's take a look at this one. So what we have is a function question, which is saying to first of all find the point of intersection of the both of these graphs. Now one of them is a linear and one is a quadratic. So we are supposed to get two solutions here because it's just say points of intersection. So let's see what we get here. So because we have to do intersection, we have to say that this equals to that because we have a y equals to y, f of x equals to g of x. So 4 plus x minus half x square equals to half x minus 2, half x square minus half x minus 6 equal to 0, x square minus x minus 12 equal to 0, x square minus, okay, for this one now we have to do middle term breakdown. We have a minus 12, so you have to think about combination of factors which can give us both 12 and this guy. Now, in case we are worried, or in case we might think we may not be able to do this, we can check our answer using a calculator and things like that. But I'm going to talk about that in a bit later on, not here, but in another video. So we have a 4 and 3 being our LCM, being our factors that can give us 12, but then we have to think about minus here. So if we do minus 3 plus 4, it will not work. If we do minus 4 plus 3, then it will work because minus 4 plus 3 gives us minus 1 and minus 12 both. So we have here minus 4x and minus 4. I mean, what I was saying is that minus 4 minus 4 plus 3 gives us minus 1, and minus 4 times 3 equals to minus 12 as well. So that's why it works. This will not work. Even though this is equals to minus 12, it is okay, but this one is not the case here. So that's what we want to ensure. Both of these scenarios are met up. So we have a minus plus 3x minus 12 equal to 0, x minus 4 plus 3, x minus 4 equal to 0, x minus 4, x plus 3 equal to 0, x equals to 4, x equals to minus 3, and f of x equals to half of 4 minus 2. So 2 minus 2 equal to 0. And for that one, we have minus 3 by 2 minus 2. So we have a minus 7 by 2. So we have a minus 3 and minus 7 by 2. Then it says find the set of values of x for which f of x is greater than g of x, which means that whatever we have here, where's that? This is something we need to be careful about. Okay, so this is f of x, not this one. This is f of x. Oops. This is g of x. So it is something like this as well. And after taking everything to this side, we get this 0 guy, right? So isn't this exactly the same? I mean, if we put here f of x greater than g of x, isn't this exactly the same as this expression just being greater than? Does this mean that also if we put everything to the other side, we are supposed to get this thing greater than 0, which means half x squared minus half x minus 6 greater than 0? And what this means is that now what we have is we could now say that this equals to x squared minus x minus 12 greater than 0. So we have here critical values 4 and minus 3. So as a result, we can say that because this is your happy face curve, this is 4 and that is minus 3. This is 4 and that is minus 3. Anything less than minus 3 will give me something positive. Anything greater than minus 4 will give me something positive. Anything greater than 4. So this is going to be therefore x less than 4 and minus 3, sorry, minus 3 less than x, sorry, x less than minus 3 and 4 less than x, or basically x greater than 4. So this is how things work here. Find an expression for fg of x and deduce the range of fg. So, okay, this is something difficult. Not for these expressions separately, because we could actually try dealing with this one. What you have to do here is, I first of all say that f of x is half x minus 2. I'm just going to write them down first. Equals to 4 plus x minus half x squared. Now the problem is that the range, the domain for both of them is supposed to be x is all your numbers. But the problem is that even though, I mean, you're supposed to do f g of x, right? It means you're supposed to do f of 4 plus x minus half x squared. So we have to just put here half of this expression here. So we have here 2 minus 2. So we have here just half x minus quarter x squared. So we can just put it like this, quarter x squared minus 2x. Then we have quarter x minus 1 whole square minus 1, x minus 1 whole quarter x minus 1 whole square minus quarter. So therefore, my range, because we have g of x is greater than minus 1 by 4. If you put minus 1 by 4 on this expression, actually, yeah, you know what? This is the range of this expression alone, which is why I can feel that this is supposed to be the answer. Not really, not really. Yeah, it's actually minus here, minus x squared plus 2x. Then this is supposed to be minus here. Then we have minus 1 by 4 plus. So therefore, it's going to be less than or equal to this guy. Then for this one, what I have to do is that we have this smallest value of k, which has for which h is an inverse. So square completion, or we can also try dy dx as well, dh of s dx. If we do that, because you're allowed to do so, we have 1 minus x, where x equals to 1 when dh of x dx equal to 0 at turning point. Because at exactly the turning point is basically where we have this whole thing greater than k. This is my x equals to k. So my k equals to 1. All right. So this is how this little guy works. K equals to 1 because for anything greater than k, I mean, this one is supposed to be x is supposed to be inverse. Why? Because obviously this little thingy. At exactly the turning point, you're going to get one single point or one single value of x and whatnot. But for anything greater, we are supposed to get two different values. So at exactly the turning point, we can go towards the right greater than and things like that, at which you're only going to get a one-to-one function. If we go, all real numbers, then this would be an invalid function because we have this guy. I mean, not invalid, but it will be invalid for inverse because the inverse graph only, I mean, can be made from a one-to-one function. Because if you do all your numbers, it would not be a one-to-one function. Our answer would actually not, I mean, be valid enough for an inverse. I mean, you get the idea what I mean. So for inverse graph, I need a one-to-one function. So if I go anything less than this one, if we are going anything less than x, I mean k equals to 1, then there will be few points on the curve which will give me two values of x for which we have this guy, which is definitely not acceptable. So as a result, I want it right from this turning point here, because from here we can go all the way there having only one value of y for one value of x, making it a one-to-one function, which is why k equals to 1, or exactly where my turning point is applicable. So that's how this question works. And for this one, what I've done is that for this question, I have just found out the function itself in its complete square form, from which I was able to directly find the range of this function. So this is something I have to be quite a bit careful about.